Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today, in this session, I am going to explain you about implementation of authentication header in IP security services. Implementation of authentication header in IP security services. So IP secure, which is a combination of both authentication header and encapsulating security payload. So that's why we can say that IP secure equals to authentication header plus encapsulating secure payload plus IKE, Internet Key Exchange. So in this session, we are going to discuss about authentication header. So the protocols and the mechanism, the protocols and implementation of service to support security at the network layer. So this IP security service is a service protocol mechanism which is happen in the layer of network layer, and it is implemented on end hosts and gateways also. So here IP security, simply called as IPsec, is a collection of protocols designed by the Internet Engineering Task Force (IETF) to provide security for a packet at the network level. So providing a security for the packet at the network level, the IP secure or IP security implements some set of protocols. So IP secure in the transport mode does not protect IP header. In the transport mode does not protect IP header, but it protects in the tunnel mode. So it only protects the information coming from the transport layer. So it protects only the data which is coming from the transport layer itself. And Internet Protocol Security, IP Secure, is a secure network protocol suite that authenticates and encrypts packets of data to provide secure encrypted communication between two computers over an Internet Protocol network. So IP Secure provides a network protocol suite that authenticates purpose as well as encrypt purpose for the packets of the data to provide secure encrypted communication. And it is used in virtual private networks. And it can protect data flows between a pair of hosts. Data flows between a pair of host to host. That means host to host it provides, host to network it provides, and network to network also it provides. So between security gateway and host. And IP secure uses a cryptography security services to protect communication over the IP networks, over the Internet Protocol networks. And it supports network level peer authentication, that is nothing but system authentication or device authentication, as well as data origin authentication, data integrity, data confidentiality, and relay protection, that is nothing but protection from replay attacks. So like the way IP Secure provides some different services. So the overview of IP Secure, we are going to understand the following concepts in the authentication header. So what are the things? The first one is what authenticated keying, that is nothing but generating keys, applying encryptions using keys, applying decryptions using keys. All these are using authenticated key. And second one is data encapsulation. With the help of both ESP as well as authentication header. So encapsulating security payload as well as IP authentication header. And security architecture. So it contains both tunnel mode as well as transport mode. And the databases, security associations, some policies, some peer authorizations. So these are all the things we are going to know in this IP security services. IP security services. So as we said in the previous sessions, IP secure is authentication header plus encapsulating security payload plus IKE, Internet Key Exchange. So from this, the authentication header plus encapsulating security payload, these two for the protection for IP traffic. These two for protection for IP traffic. And the IKE for setup keys and algorithms for both these. For both authentication header and ESP. So the Internet Key Exchange mechanism generate keys or generates keys, session keys, private keys, public keys using some algorithms. So generating keys and algorithms for authentication header as well as ESP. But here authentication header plus ESP provides a protection for IP traffic. Provide a protection for IP traffic. So authentication header provides integrity and origin authentication. Integrity and origin authentication. And ESP also having confidentiality. ESP is also having confidentiality. So the both authentication header plus ESP stands for providing integrity as authentication as well as confidentiality purpose. So IP secure is not a single security protocol. IP secure is not a single protocol. Instead, IP secure provides a set of security algorithms plus general framework that allows a pair of communicating entities to use whichever algorithms provide security appropriate for the communication. So which type of algorithm is providing a communication to the which type of communication modes. So providing better algorithm for better communication. That is what the IP security provides, a set of security algorithms as well as general framework that allows the both pair of communicating entities to use different types of algorithms. So IP secure authentication header. So instead of changing the basic datagram header or creating an IP option, IP secure uses a separate authentication header to carry authentication information. So it says that it doesn't have any other datagram header. It directly involves the authentication information with the help of authentication header. Directly involves authentication information with the help of authentication header. So here in this figure, the figure A shows that IP header format, which does not contain authentication header, which just contain IP header followed by TCP header followed by TCP data. But in this second figure, the authentication header added in this IP header format, which is called as IP secure. So IPv4 header followed by authentication header followed by TCP header and TCP data. So normal IPv4 data header format does not contain any authentication header, but authentication header added in IP header format contain authentication header format. So in the normal IPv4 header format contains only 3 fields, but in the authentication header format fields contain 4 fields. Authentication header plus IPv4 header plus TCP header plus TCP data. So this is the way you can understand authentication header frame format. As the figure shows that IP secure inserts the authentication header immediately after the original IP header. So original IP header, after that IP header, the authentication header added, but before the transport header. So the authentication header added after IP header and before TCP header. So what the authentication header actually contains? What the authentication header field actually contains? So in this diagram shows that authentication header fields. So what are the fields? Different types of fields contained in the authentication header. So the first field is what? Next header. The first field has next header, and second one is what? Payload length. Next one reserved field. The next one security parameters index. Next one sequence numbers. And next one authentication data. Authentication data. So these are all the fields contains in the authentication header, which is after Internet Protocol header, before TCP header. So now authentication header fields are saying that next header, payload length, reserved field, security parameters index field, sequence number, authentication data. Authentication data. Now the next header indicates that what? In the authentication header field, the next header indicates that it is a TCP header. Next header indicates that it is a TCP header. And the payload length. So how much data it is going to be carried out? How much data it is going to be carried out? And the reserved for extra added field to carry out the data. For extra added field to carry out the data. And the security parameters index. So what are the parameters you are going to take for the providing security for the next layer? So the parameters you have to be mentioned. And the sequence number of the programs. Sequence number of the data. And authentication data. So which type of data you are going to be authenticated with the help of variable you are going to mention. So here the payload length field does not specify the size of the data area in the diagram. Instead, it specifies the length of authentication header. It specifies length of authentication header. And remaining fields are used to ensure security. So what are those fields? One is sequence number, security parameters index field, authentication header field. So authentication data field. So sequence number contains unique sequence number for each packet sent. Unique sequence number for each packet sent. The number starts at 0 when a particular security algorithm is selected and increases monotonically. So whenever it started to use the security algorithms with the help of number starts with 0, when a particular selection of security algorithm, automatically it increases 1, 2, 3, 4. Like the way the sequence numbers are increased based on the security algorithms that are provided. The security parameters index field specifies the security scheme that used. Specifies that security scheme that used, and authentication data field contain the data for the selected security scheme. The data selected for the security scheme. So the next header, it is an 8-bit field which identifies the type of what follows. The type of what follows. And similarly, payload length. It is an also 8 bits long field, contains length of authentication header expressed in terms of 32 bits minus 2. 32 bits minus 2. And reserved field, it is reserved for future uses. And its length is 16 bits and it is set to 0. It is set to 0. And the security parameters index field is a 32-bit field. And the sequence number field is also 32-bit field. It is monotonically increasing the counter whenever the security algorithms are added, which is used for replay protection. And authentication data, this is a variable length field. It is a variable length field depending upon the data entered into the packet. So it contains the integrity check value and is padded to 32 bits for IPv4 and 64 bits for IPv6. And authentication header is used to provide integrity as well as authentication to the IP datagrams. So it provides both integrity and authentication to the IP datagrams. IP datagrams. So replay protection is also possible. Replay protection is also possible here. The services are connectionless. The services are connectionless. That means they work on per packet basis. They work on per packet basis. That is nothing but the data is transmitted in the form of datagrams. So hence the service is wireless. It is working on basis of datagrams basis or packet basis. So authentication header used in two modes. Authentication header used in two modes. The first one is what? Transport mode. And the second one is what? Tunnel mode. First one is what? Transport mode. Second one is what? Tunnel mode. So IP security modes, transport mode. So it is used to deliver services from host to host. So delivering the services from host to host or from host to gateway only. Host to host or host to gateway, it provides the services. And usually within the same network, but can also be end to end across networks. Similarly, tunnel mode is used to deliver services from gateway to gateway. Delivered services from gateway to gateway or from host to gateway. From host to gateway. Usually, gateways owned by the same organization. Gateways are owned by the same organization. So within an insecure network in the middle. With an insecure network in the middle. So this is the IP secure in transport mode. So here the IP secure in transport mode provide the services from host to host or else host to gateway. Host to host or else host to gateway. So here this is one host and this is one host. And providing the service or utilizing the services in between these hosts. So this is an internal network and this is an external network. So the encrypted TCP sessions are allowed to connect both host and second host. So here end-to-end security between two hosts. So typically client to gateway, example PC to remote host, and it requires IP security support at each host also. And here the authentication header in transport mode. So this diagram shows that without authentication header, and this diagram shows that with authentication header. And authentication header transport mode. In the transport mode, the IP header format is not involved. IP secure header format is not involved. But in the transport mode, tunnel mode, the IP secure is provided again to provide the security. So here, this is the original IPv4 datagram, and this is the authentication header added IPv4 datagram. So in this original IP datagram, which contains both IP header, TCP header, and TCP data. So IP header, TCP header, and TCP data. So that is what actually the original IPv4 datagram contains. So here the IP header followed with all the fields like version of the field, H length of the field, type of service, header length of the field, type of service, packet length, ID, flag offset of the field, time to leave field, protocol indicates the next protocol, that is TCP protocol indicates, and the header checksum indicates source IP address, destination IP address, and the TCP header protocol which contains 6 bits, and TCP payload. TCP payload is nothing but TCP data. So this is all not protected by authentication header. But when authentication header added in the IP secure, automatically this all entire data is protected by authentication data. Entire data is protected by authentication data. So here this is IPv4 header. After that, after IP header, the authentication header are added. After authentication header, TCP header added. So IP header, in the IP header field, the protocol, next protocol indicates that authentication header. And the remaining all fields are same as we seen in the IPv4 datagram. So here authentication header point out to the next header TCP. Authentication header point out to the next header TCP, which contain TCP header plus TCP payload. That is nothing but TCP data. So here authentication header contains next header, authentication header length, reserved field, and security parameters index field, sequence number of the field. So these are all authentication header fields. Along with this authentication header field, next header indicates that next header is a TCP header. Next header is that TCP header. So like the way we can understand that IPsecure provide the security service in transport mode with the help of authentication header added. So next, IPsecure in tunnel mode. So it provides the services between both host to gateway or gateway to gateway. Provide host to gateway or gateway to gateway. So here internal traffic defined behind gateways not protected. So internal traffic behind gateways, those who are away from the gateways are not protected. So typical application example virtual private network, and it requires IP security support at gateways level. So here all these hosts are connected with corporate network. All these hosts are connected with the corporate network, and these all corporate networks are interconnected with some type of network. So here the providing services in between both host to network as well as network to network. So this is all the local area network which is incorporated with all the hosts, Now the services are elaborating from network to network. So here we can see this is the user system with IP secure, and this is the firewalls, this is the hosts, and this is the Ethernet switch, and this is the network device with IP secure. It's contain IP secure. So this is also which contain IP secure and Ethernet switch, and these four are the systems. Those are nothing but hosts. And this is the virtual private network implemented inside of the network. Implemented at the inside of network. So here the providing services from network to host or else network to network. So this is one type of network, and this is one type of network. So providing services this network to network or else system to network as well as system to network or system to network. So here because of this IP secure authentication header provides the security, IP security, this data is not going to be hacked by hacker or not going to be modified by intruders. So this is one virtual private network implemented in the public network. So this indicates IP traffic protected by IP secure. So this is protected by IP secure. This is also protected by IP secure. It is incorporated with all the local area networks. There is nothing but private networks across public network. So these are all the ways. That providing the services from host to network or else network to network. The tunnel mode can be used to implement a secure virtual private network, and it is a private network that is configured with the public network. So in the above figure shows the IP secure tunnel mode for implementing VPN operations. An organization maintains LANs at dispersed locations. A non-secure IP traffic is conducted on each LAN. For traffic offsites through some sort of private or public network, IP secure protocols are used. The IP secure networking device will typically encrypt and compress all traffic going into the internet or other network, and decrypt and decompress traffic coming from the network. These operations are transparent to the workstations and the servers on the LAN. So these are the operations that are transparent to the workstations as well as servers in the LAN. And secure transmission is also possible with the individual users. So secure transmission is also possible with the individual users. So who connected to the internet or other network, who connected to the internet or other network. Such user workstations must implement the IP secure protocols to provide security. IP security protocols provide security. So this is all what we understand from this diagram, which is implemented with the help of IP security service. That is nothing but with the help of authentication header. With the help of authentication header, the private network we are going to access across the public network. And IP secure in authentication header tunnel mode. So IP secure in authentication header in tunnel mode. So this is all original IPv4 header, and this is all TCP data, which is not protected by authentication header. But this, which is having authentication header in IP security mode, IP security tunnel mode, is contain IP secure in additional mode. So this is one IP header, and here also one IP header. Here also one IP header. That means IP header remains the second time in the authentication header. In the authentication header. So now from this authentication header onwards, it is moving forward to the next header, that is TCP header. Next header, that is TCP header. So here you can see all the fields like version of the header, header length, type of service, packet length plus authentication header plus IP header, and ID of the packet, flags, flag offset, time to live, protocol, what protocol it is indicating for the next one, that is protocol equals to authentication header, header checksum, source IP address, destination IP address. These are all the fields contains in the IP security service. And here again it contains the next equals to IP and authentication header length, reserved field, security parameters index field, sequence number field, and authentication data. So these are all the fields contained in the IP header with authentication header. And this also same IP header, and last TCP header plus data. So these are all the TCP header plus data is authenticated data, and which is protected by authentication header. So this is the way we can understand that tunnel mode operates. Tunnel mode provides the services between both network to gateway or gateway to gateway or host to gateway. Gateway to gateway or host to gateway. And this is the illustration of the tunnel mode. This is the tunnel security association. This is the normal host, local host using local intranet with the help of, it provides the services with the help of gateway to the tunnel security association. And similarly, the gateway provides services to the additional gateway. And again, gateway provides the services to the host. So that means tunnel mode says that what? It delivers the services from host to gateway or gateway to gateway. Host to gateway or gateway to gateway, it delivers the services. So IP secure protects communication on the insecure part of the network. So here we can see the differences, transport mode versus tunnel mode. So transport mode secures a packet payload and leaves IP header unchanged. Payload and it leaves IP header unchanged. That means it contains IP header and IP secure header and TCP or UDP header plus data along with this data. So here IP secure header indicates that either it is authentication header, either it is ESP header, or either it is IKE. So coming that all this, any of these three, we can place it as a IP secure header. And tunnel mode encapsulates both IP header and payload into IP secure packets. So IP header is gateway, and IP secure header, IP header real destination, and TCP or UDP header plus data. So IP header real destination, IP secure header, both are belongs to either authentication header or ESP header or IKE header. So which describes the difference that added in the packet frame format. And here use cases summary, we can see that the delivery of the services from host to host, that is nothing but a transport mode or tunnel mode. So host to host, the connection is to be secure, the secure connection host to host, that is nothing but secure tunnel way. And the gateway to gateway, so provide the services in the tunnel mode, the services are in tunnel mode, and here the gateway to gateway, the services are offered in between the gateway to gateway, host to gateway, as well as gateway to gateway, as well as gateway to host, gateway to host, gateway to host, and here host to gateway also. So tunnel mode, it provides the services from tunnel mode, that is nothing but a host to gateway or gateway to gateway, gateway to gateway. So this is the way of understanding the services offered in between the tunnel mode and the transport mode in authentication header. So these are all the use cases of the summary. We are delivering the services from transport mode or tunnel mode in the field of authentication header. So we will look once again what are the topics we discussed in this session. So authentication header, it followed in the IP security services. It followed in the IP security services. So which contains both authentication header and ESP as well as IKE. So internet key exchange provides authentication mechanisms with the help of generation of some keys. And data encapsulation provides encapsulation and the confidentiality of the data. And security architectures provides the delivery of the services in the two modes like a transport mode as well as tunnel mode. And the IP security formula, the IP secure is nothing but it is a combination of both authentication header plus encapsulating security payload plus internet key exchange mechanism. And this is the header format of IPv4 header format, and IPv4 header contains authentication header also. So how the authentication header is in the part of IP secure. So here you can see the IP header, the next header of IP header is authentication header, and next header of authentication is TCP header, which points towards the TCP data, and here the ESP and the authentication header fields are showing that the fields are next header field, payload length field, reserved field, security parameters index field, sequence number field, authentication data fields. So which holds in the form of variable. So authentication data is a variable, we can say that. And here the authentication header fields are there, and the authentication header used in two modes we are explaining. The one is transport mode and the second one is tunnel mode. The transport mode delivering the services from both host to host as well as host to gateway, as well as host to gateway. But in the tunnel mode, the services are offered in between gateway to host or gateway to gateway, So this is the IP security service offered in the transport mode, which is using encrypted TCP session to communicating both hosts. Similarly, authentication header in transport mode, which offered services in the authenticated way. And here the IP security tunnel mode, so provide the services between host to network or network to network, host to gateway or gateway to gateway. And these are the example virtual private network implementation with the help of tunnel mode, in the real time example. This is the virtual private network implemented with the tunnel mode across public network. So public network, on the basis of public network, how the virtual private network is implemented in the tunnel mode. And the figure shows that all about the virtual private network. And here the tunnel mode implements the IP secure in authentication header, which implements IP secure is again, And here the tunnel mode illustration here indicates that the services from host to gateway are gateway to gateway. Host to gateway are gateway to gateway. The services are transferred, the services are delivered in between those two. And here we can see the difference that which contains in the transport mode and which contains in the tunnel mode. So transport mode contains IP header, real destination, IP secure header, and TCP header plus data. But while in the tunnel mode encapsulates both IP header and payload into IP secure packets. So IP header and payload, which both are encapsulated into IP secure packets. So this is the difference, we can say that. And these are all the host use cases that we are having the services from host to host or gateway to gateway or host to gateway. So this is all about the authentication header in the IP security services. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.